Hi folks, we're going to take a look at the solutions to the Unit 4 quiz. So let's start with number 1. It says the angular speed of a wheel is 1200 radians per minute, and they want us to determine the number of revolutions in 1 hour. Okay, so most of the questions we've seen have gone the other way, but again, it's just a matter of changing the units here. So I'll start with 1200 radians per minute. Okay, and the first thing I'm going to do is I'm going to change the 1200 radians into the number of revolutions. Okay, so there's 2 pi radians in each revolution, so this is just 1200 divided by 2 pi, and now it's revolutions per minute. Okay, and so now I'm just going to change the minutes into hours, so that means I have to multiply the denominator by 60 to get 1 hour, so I'm going to have to do the same thing to the numerator. So let's simplify this here. This is 600 over pi times 60. Okay, and so this is now going to be revolutions per 60 minutes or 1 hour. Okay, and now we can just quick multiplication, 36 with 3 zeros over pi revolutions per minute, per hour. Okay, and there's the exact answer. Now, given that this question is a context, I'd be fine with you giving me an approximation. So let's calculate that approximation, 36,000 divided by pi. Okay, so we have about 11,459 revolutions per hour. Okay, so again, just to recap, start with the information that you're given and just carefully change the units as you go along. Okay, let's move on to number 2. So here they want us to determine the exact value of some trig ratios. So let's start with this one here, secant of 5 pi over 4. Now at this point here, you should be recognizing 5 pi over 4 as a special angle. So the first thing I'm going to do is draw myself a little diagram here. So here we've got pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So 5 pi over 4 is going to be in the third quadrant. Notice how I know that it's going to be right in between. So I try to make the diagram at least a little reflective of the actual angle. So my related acute angle is pi over 4, and so here I've got 1 root 2 as my special triangle, and here both the x and y values are negative. So secant, of course, is the reciprocal of cosine, and so instead of being x over r, it's r over x. So my answer here is negative root 2. Okay, so let's move on to part B. So by the way, I would expect to see some work, and in this case here, showing me the diagram would be sufficient work, as I would expect you not to just stick this in your calculator. Okay, so if we take a look at this one here, 7 pi over 12 is not a special angle, okay? But hopefully we can write it as some combination of special angles, and here I can see that 7 pi over 12 can be written as, again, think everything in terms of over 12. Okay, it's 3 pi over 12, which I know is going to be a nice angle, plus 4 pi over 12. So here 3 pi over 12 is just pi over 4, and 4 pi over 12 is just pi over 3. Okay, and so now I can rewrite cos of 7 pi over 12 as the cosine of a sum of 2 nice angles. So it's the sum of pi over 4 plus pi over 3. And now I can apply my identity for the cosine of a sum. Okay, so here we have cos of pi over 4 times cos of pi over 3 minus sine of pi over 4 times sine of pi over 3. Okay, I'm going to draw myself my little diagrams here just to be sure that I don't make any silly mistakes here. So for pi over 4, midway through, so again 1 root 2, and then pi over 3 is the larger angle. Okay, so notice how I exaggerate it just to make sure I don't make any silly mistakes with my side lengths. So 1, 2, root 3. Okay, now one quick way of remembering which goes which here is remember that the hypotenuse needs to be the longest side. So 2 is bigger than root 3. So hopefully that helps you not make any mistakes. Okay, so here we've got pi over 4. Cos of pi over 4 is just 1 over root 2. Cos of pi over 3 is just 1 over 2. Okay, minus sine of pi over 4 is again 1 over root 2. And then sine of pi over 3 is just root 3 over 2. Okay, and now let's just simplify. So we've got 1 over 2 root 2 minus root 3 over 2 root 2. So that's 1 minus root 3 over 2 root 2. Okay, now I'm okay with an answer given with a square root in the denominator, but if you did want to rationalize, remember what you have to do. You have to multiply top and bottom by root 2 in order to get rid of that square root in the denominator. So in the numerator you have root 2 minus root 2 times root 3 is root 6. And in the denominator here you have root 2 times root 2 is 2 times the original 2, which is 4. Okay, so either one of these answers would be acceptable. Okay, let's move on to number 3. So here they give us some information about this angle X. They tell us that it's in the second quadrant. Okay, so somewhere here we have some angle X. So remember, this is the actual angle X. Okay, and they're asking us to determine sine of 2 times that angle. Okay, now if I'm asking you to do this without a calculator, so that should have been part of the instructions on a test, that's how it'll be given. Okay, well, in order to determine sine of 2x, I have to look at the information I'm given. I'm given information about the angle x. So my first step should be to use my double angle formula to turn that into 2 sine x cos x. Okay. Number 2, though, is I notice that I need sine and cosine of x, yet I'm given information about tangent. So this is where now I'm going to use my diagram, because here I'm going to use this ratio to represent the x and y values on my terminal arm. Okay, so here, since tan is y over x, okay, and the y value obviously is going to have to be positive, so this is going to be 12, and my x value is the one that's going to be negative 9. Okay, and in order to determine sine and cosine, well, I need to determine the r value. Okay, so r is just equal to square root of 12 squared plus negative 9 squared. Okay, and that's equal to 144 plus 81. So that is 5, 12, 2, 225, which is just equal to 15. Okay, so nice number there. So now I can go ahead and calculate my sine x and cos x. So we got 2 times, so sine x is just going to be 12 over 15, and cos x is just going to be negative 9 over 15. Okay, and so here, what do we have? We have some fractions that reduce quite nicely, so let's start by reducing this. So that's going to give me 4 over 5, and this is going to give me 3 over 5, and so we have negative 8 times 3, 24, over 5 times 5 is 25. So there's my exact answer. Okay, so just to recap here, notice that we didn't ever actually determine what x was, but given the information with tangent, we were able to determine sine and cosine by using good old Pythagoras. Okay, so let's move on to page 2. Just get page 2 there. Okay. Okay, so number 4 here. Okay, it says given that sine of 7 pi over 8 is approximately equal to this number here, they want us to approximate cosine of 8 pi over 9. Okay, so at this point here, you want to notice certain patterns. So they're giving us information about a sine value, and they want us to determine information about a cos value. Okay, so likely I'm going to be working with my correlated acute angles, or my correlated angles. Okay, if I was given information about sine and I was being asked for information about another sine value, then I'd be looking at my related angles. So first thing I notice is that 7 pi over 18 is somewhere in the first quadrant. Okay, and 8 pi over 9 is almost equal to pi, so that's going to be in the second quadrant. Okay, so what I'm hoping is going to occur is that if I can show that 8 pi over 9 is just equal to pi over 2 plus theta, okay, the correlated angle in the second quadrant, well then I can use my my results. Okay, so here let's see if that's the case. Okay, so let's test that 8 pi over 9 is indeed equal to pi over 2 plus our theta, which in this case here is our 7 pi over 18. So let's just calculate that. Pi over 2 plus 7 pi over 18. So this is 9 pi over 18 plus 7 pi over 18, okay, which is equal to 16 pi over 18, which is indeed 8 pi over 9. Okay, so that means we have that cos of 8 pi over 9, that thing that we're looking for, can be written as cosine of pi over 2 plus 7 pi over 18. Okay, and this now allows me to use my correlated identities. So here I have a cosine in the second quadrant, which is going to be related to a sine value in the first quadrant, okay, namely this angle theta, 7 pi over 18. But since cosine is negative in the second quadrant, I know that this relationship must be a negative relationship. Now, of course, you can look this up on your formula sheet, but I'm just reasoning it out. And so here we know that sine of 7 pi over 18 is approximately equal to that. So this is approximately equal to negative 0.9397. Okay, so just to recap here, when you're trying to show that a sine value and a cosine value are equal or negatives of each other, you need to be thinking about using correlated angles. Okay, so let's do the last question here. Okay, so they're asking us to prove this identity. So step one, of course, is to determine which side to start with. And here I don't think there's any argument to be made to start with the left-hand side, so I'm going to be starting with the right-hand side. Okay. So here I don't have a formula for cosecant of 2x, but given that cosecant is 1 over sine, okay, I can write this as 1 over sine 2x, okay, minus, now same thing here, I don't have a formula for cotangent of 2x, but I do have a formula for tangent of 2x. So I could write this as 1 over tangent of 2x, okay? And if you did that, you'd be able to, solve this. It would take a little longer. However, because I've got this sine 2x in the left term, right, and I know that this is going to be equal to 2 sine x cos x, I know that at some point I'm going to have to work with sines and cosines. So this is why I would suggest, instead of writing this as 1 over tangent, write it as cos 2x over sine 2x, which is an alternate way of writing cotangent. So we know that tan is equal to sine over cos, cotangent is equal to cos over sine. And in doing this, I notice something really nice occurs, okay? Is that I've got the same denominator here. So now I can subtract these very easily. 1 minus cos 2x over sine 2x. Okay, so in the denominator, there's really no choice. I have to turn this into 2 sine x cos x. It's in the numerator that I do have some choice. Okay, now we've seen this trick before. Is we have this constant 1, okay, and here there's arguments to be made, cos squared minus sine squared. That might work because if we have both sine and cos. But if I choose the one that'll allow me to eliminate this 1, okay, well, that'll make my expression in the numerator simpler. So that's why I'm choosing 1 minus 2 sine squared x. Okay, now notice here how I put this in brackets. Okay, because I'm subtracting the whole expression. If you don't, you might be tricked into thinking that 2 cos squared x minus 1 would also work. Okay, that would not, because I'd be subtracting a negative 1, so adding 1. So this now makes things quite easy, because 1 minus 1 is 0, and the negative of negative 2 sine squared is just 2 sine squared x over 2 sine x cos x. So here 2 over 2 is 1, and one of the sine x's in the numerator reduces with the sine x in the denominator, and I'm just left with sine x over cos x, which of course is equal to tangent of x. And there's my left-hand side. Okay, and so my proof is complete. So just to recap here, okay, in the same way that we always keep an eye out on the other side of the equation as I might be going through the proof of an identity, you also want to keep track of what else you have in your expression that you're starting with. In this case here, because I knew I was going to be forced to work with sines and cosines, that's why it made sense to turn this cotangent immediately into sines and cosines. Okay, so that's it for this quiz.